Good morning, good afternoon, or good evening, depending on where you are in the world. And thank you for joining this learning experience brought to you by Harness. My name is Cody, and welcome back to Techstrong Learning, where we have an exciting presentation ahead. Before we dive into things, I do have just a couple of notes I'd like to review with everyone. First off, we are recording our session today. So if you happen to miss any of our discussion, if you'd like to watch at a later time, or if you'd like to share this with your team, you will be receiving the on-demand replay via email shortly after we conclude this live session today. Now, if you'd like to get involved with our presentation, there are a couple of ways to do so. The first way is to use the chat tab on the right side of your screen. So when you find that chat tab, I'd like you to let us know that it's working by telling us where you are from. I see Florida, France, Greece, British Columbia. We're coming from all over today. Hello, Sydney. Additionally, if you have any specific questions, we want you to direct those questions to the Q&A tab. If you do put your questions in the chat, I will simply be moving them to the Q&A tab. So if you see your question disappear, worry not, we are still keeping track of it. And finally, we will be selecting 2 of our most engaged attendees today to win a $50 Amazon gift card. So ways that you can become engaged with us is to simply send in your chats, your questions, and of course, filling out our post-webinar survey. So today's topic is coding is enjoyable, but the rest is still toil. How can generative AI help? I'm joined today by Harish Dodala, VP of Product Management at Harness, and William Wisman, Principal Software Engineer at Harness. So Harish and William, thank you all so much for joining us today on Techstrong Learning. Harish, do you want to dive us right into the material?
Yes, thanks, Cody. Appreciate it. Hello, everybody. Welcome to the session today. Excited about presenting what the theme essentially is that coding is enjoyable, but the rest is still toil. So we're going to dive into what this really means and how can GenAI help. By way of introduction, my name is Harish Dodala, and I lead product management at Harness. Harness is a modern software delivery platform. And my background essentially is in the DevOps space. I've been working in DevOps for the last 5 years. And prior to that, I used to work at a number of startups and large companies. I started in machine learning and AI. So I've worked at natural language processing as an engineer prior to transitioning over to product management. So I'm super impressed by the kind of advancements that we've achieved over the years, including the most latest in GenAI. So excited to be talking about the theme today. I'm also joined by William. William is a principal engineer at Harness, and he is part of the security orchestration team. And he's got a bunch of exciting demos lined up at the end of the session. So we're going to be walking you through those as well. So to dive right into the agenda, the areas that we're going to cover is, firstly, we've seen a lot of innovation around coding efficiencies and generating code in generative AI. We're going to talk about some of the innovation that is happening and also needs to happen beyond that space. Like, how do you sort of encompass the entire software delivery lifecycle and look at sort of the advancements and also the associated toil in the software delivery lifecycle as a whole. So we're going to dive into what that toil really means in software delivery. We're going to discuss different facets of software delivery and where we see this toil. And we have some examples, nuggets, anecdotes to share about how GenAI can help in each of these facets of software delivery. So if you're a developer, if you're a DevOps engineer, a platform engineer, I'm sure you'd find a lot of these very helpful and relevant. And finally, we have a demo of sort of diving into some of these themes as well. So that's something which William is going to be doing at the end of the session. So to sort of set the stage in terms of what the theme and the topic for today's discussion, as I was mentioning, that we see a lot of coding advancements with generative AI today, with some of the latest tooling around generating code, generating test cases. That's something which is rapidly advancing. In fact, in a survey that was recently published by Stack Overflow, the numbers were like developers are or some companies and some organizations are seeing an improvement in about 30-40% in terms of improvements of coding efficiencies. Now that could be for maybe some set of use cases, a set of scenarios specifically, but some companies may have realized it, some companies may sort of be still in that journey. But one thing to sort of realize is like this, post this aspect, post the coding aspects, there is still a lot of things that ought to happen before the features actually reach the hands of the customers. Now, what are those? It has to be the code has to be built. It has to be tested. We have to make sure that it's secure. It's deployed in different environments, from staging environments, pre-prod, and finally into production. We have to harden it, ensure that it's the code is secure, and finally optimize it in terms of coding efficiency, in terms of costing, in terms of identifying any kind of software delivery bottlenecks. And finally, we deploy that code, and those features are released in the hands of customers. And this is obviously an iterative and ongoing process. A lot of advancements we see is sort of in this area, and while this is the most enjoyable part of a developer's life, like if you think about the time that we really enjoy the aspect of coding, we really enjoy the aspect of creativity. It's sort of analogous to, as a writer, you really enjoy writing. Like if you're a writer, you enjoy writing, whether it's prose, poetry, whatever. But what happens after that? What happens when you have to actually publish your book, or when you have to distribute your book and figure out exactly what channels to distribute it on, or how do you monetize it and things like that? That's kind of where some of the toil as well is, right, as a writer. So that's the laborious phase of the software delivery lifecycle, which are these aspects which we're going to be delving deeper into today. So in a survey that we published recently by our CEO Jyoti in a LinkedIn poll, what we discovered was about 3 hours is kind of what on an average developer spend time in actually coding. Now this is something which we definitely need to sort of the amount of time that used to be spent in coding traditionally is potentially reducing, and obviously with the coding efficiencies, it is going to reduce even further. And where it used to be the case where you'd spend, say, 4 days coding and 1 day maybe looking at the other aspects, now it's the other way around, right? Where you're spending about 1 day or 2 days coding and the other 3 days sort of in the toil of refactoring that code, trying to generate test cases, securing it, hardening it, verifying it, optimizing it, and things like that. So where is that coding toil really? Like, how is that coding toil really being, or non-coding toil being distributed across various aspects? So we see that time going towards waiting on bills. It takes time to actually wait for the bills to complete, for the test cases to complete, for troubleshooting, and if once it enters once we sort of start to deploy it, we look if there is any issues with the deployments, or if there are any dependencies, external dependencies, if there are approvals that you're waiting on, all of that leads to toil as well. And oftentimes security also is sometimes it might be an afterthought. And it can come in the way of velocity. So that's sort of a trade-off that one needs to make as well. So we can look at sort of that also takes up some of the toil. Creating and maintaining those pipelines, trying to manage cloud costs. Now, cloud costs also is an important facet of software delivery, where you want to make sure that you're efficiently using your resources. And you're doing that sort of both at design time as well as at the time of provisioning your infrastructure. And finally, some of the tribal knowledge that exists, things like stand-ups even. I mean, all of that is still toil, right? All of that is still time that's eating into the time that you want to spend in actually coding. So let's dive into some of these aspects. Let's dive into each facet of the software delivery, and let's take a look at what exactly toil means in the realms of continuous integrations. Now, as the feature and functionality increases, the amount of generated code also increase, and the entropy of the code increases. Now, what do you mean by entropy? Entropy essentially is the complexity of code, and a more elegantly written code basically might be, or even at the beginning, you might not have a lot of complexity. But as the code starts to build, as you start adding more features, as you start having more versions, a larger code bases, more repos, all of that starts to increase the entropy. and it starts to increase the complexity of this code bases as well. And what this leads to is also longer times to build. It might lead to more time to identify the specific test cases, whether it's unit tests or integration tests. More importantly, the integration tests. Now, some of this might also be running on outdated CI infrastructure, and there could be a difference in sort of how this is being run across your test, your dev, prod environments, and that could potentially lead to drift as well. So now moving on, looking at the security aspects. Now, security is also an important aspect or an important facet of software delivery. And oftentimes, like not running these scans, not running the security scans can lead to accrual of technical debt, which could lead to sort of shipping insecure code, which ultimately will have to be addressed at some point in case that some customers might have very stringent security requirements, and you have to sort of look at your artifacts, ensure that it's free of all the vulnerabilities, the CVEs, and so on, and finally and ship it. The scanners themselves might, in some cases, be outdated on this process, and they might not be very well integrated into the delivery pipeline. So the two aspects might be in silos, the way you sort of run these scans and identify these issues, and you might be pinged as a developer at a later point to sort of go and fix all those vulnerabilities, go and clean up the code base, clean up the artifacts before it's actually shipped to the customers. And that can also lead to tech debt, and that can also lead to operational overhead and toil. Now, while that happens, you also have to sort of balance velocity with addressing vulnerabilities. Right? You don't want that to be an impediment towards velocity. And sort of looking at deployments, when you do deploy, you want to ensure that if in case there is any issues, in case you need to roll back, that you're able to roll back instantly. You can roll back intelligently based on issues that is discovered before it sort of cascades into something bigger. And as you start to, and we think about generating code, but essentially generating pipelines also is an interesting use case for AI. Like, how do you generate a pipeline before, how do you provision it? How do you gather the required infrastructure resources that's necessary and deploy it? All of that potentially can be optimized as well. And as these pipelines start to grow, in especially large organizations, we also see a lot of duplications in these pipelines. Different teams might be using it. So how do you sort of consolidate all of this? How do you standardize it? And so on. Finally, the deployment errors, the deployment issues that come about. Again, some of these could be standard errors, standard exceptions, and it can be handled. It can potentially be handled using generative AI as well. So how do you reduce the toil required for troubleshooting these pipelines is also another interesting use case. Governance of pipelines. So in case you want to govern aspects of, for instance, I don't want to deploy unless a certain number of tests have been passed in pre-production. I don't want to deploy unless there is an approval test. You need to sort of think about how you bring this governance into deployment processes as well. And those are also areas where GenAI can potentially play an important role in. Now, feature flags. Now, feature flags is obviously an interesting aspect of increasing velocity for increasing the velocity of your releases. Now, wrapping code behind feature flags and doing so will give you that level of experimentation, the ability to run A/B tests, figure out if you want to expose a certain feature to a certain audience for what periods of time, and all of those aspects. Now, while that's important, and while the velocity of releases also is important, what that can lead to is very cluttered code bases. You can have inconsistent behavior, especially if you don't go and clean up those flags. We've seen many instances of sometimes unwarranted behavior because a certain flag has been left turned on, and it's being rolled out. It had been rolled out to an audience that it was not supposed to, or it has a state that it should not have. So we sort of have to deal with all these challenges of old flags, of flags leading to inconsistent behavior. We have to refactor the code, clean up all the code base with all the flags, and that can also sometimes result in toil. You might have to dedicate specific sprints for that, and see how you can address that, and that can accrue as technical debt over time if it's not cleaned up upfront. And another aspect of toil in software delivery is the mounting cloud costs. And there was an interesting session by Werner Vogels, who was the CTO of Amazon recently at reInvent, where he talked about architecting for the cloud based on costs. Very interesting session. If you haven't checked it out, I urge you to go check it out. So where he talked about how you sort of have to think about managing costs and optimizing for your architecture at design time. And upfront, right, as much as possible, especially in this kind of a macroeconomic environment where companies are looking to optimize their cloud costs and bring it down and ensure that they are only consuming the resources that they need. It's important to sort of think about those aspects. But even while you're sort of at runtime, and even when you're sort of looking at operating your pipelines and looking at the ongoing feature delivery, you also have to look at how you estimate the right amount of resources that's necessary and only utilize what is necessary, because the rest of it is waste, right? And addressing some of that also can become toil. That can accrue as technical debt. Sometimes you might have to go and re-architect your design. You have to figure out if I'm logging too much, if my logging costs are extremely high, or how can I optimize my queries. So sort of dealing with this at design time, dealing with this optimization sort of as part of your software delivery can help bring that into control. And there are potentially some interesting ways in which you can do that with generative AI, which I'll talk about in a minute. And the bottlenecks for that might impact software delivery and the velocity also ought to be looked at very closely. So, for instance, as a leader or an executive, if you want to look at some of these metrics, understand exactly what types of metrics are reflective of the velocity, of the efficiency, and how you can optimize for all of that. You should ideally be able to query the data, talk to your systems, using natural language, and get the answers that you need. And that's being sort of aspirational, but it is also becoming very real with generative AI, and we'll show you some examples in how we can sort of achieve that as well. So we talked about Toil and Toil as it exists across the software delivery lifecycle. I only picked a few facets. Of course, there are a ton of them, including, for instance, resilience and reliability and so on. But I only give you a few examples. Now let's talk about how generative AI can help eliminate this toil across each of these different facets. Starting with continuous integrations. Now. One aspect that you can look at is you could use AI to sort of analyze the code base, figure out what has changed specifically from the previous version, and you could optimize for those builds and optimize for those build times and test times. You could, based on what the changes have been from previous versions to the current version, you can only select the tests that might be necessary, and you don't have to run all of the tests. And this can significantly reduce the amount of time that it takes. So you don't have, as a developer, you don't have to wait for the builds to complete, or for a long time for these builds to complete. Now, it is important to generate these test cases automatically using generative AI as well. But how do you generate only the test cases that you need? How do you sort of look at only the ones that has changed, or that is that you have to look at in order to significantly improve the time that's required in order to run these builds and tests? You can potentially use generative AI for recommendations in terms of what types of build infrastructures that this should run on, and how you can load balance that as well, which can ultimately also help with significantly improving the build times. You can use that to analyze the build failures. Now, when there's a build failure that you encounter, you don't necessarily have to switch tabs, go to Stack Overflow, figure out exactly what the exception was, what the issue was, come back and do it. You could get this as a recommendation. You could put the AI could essentially analyze hundreds of thousands of log lines, look for common failure patterns, potentially predict issues even before they occur, and recommend what the fix ought to be. And in terms of recommendation, you can raise a PR automatically and see if that's something that would address the issue. So those are some of the examples, and we'll show you some of these in action as well. Moving on to the next one, security. Security, in order to access code for, you're sort of, as I was mentioning earlier, sort of trying to balance between how you can velocity and addressing vulnerabilities, making sure that you're shipping code that is free of security issues and so on. This is an issue that that you have to constantly sort of grapple with and balance. Now, trying to summarize what these issues are by looking at there's a ton of publicly available data sets today, and looking at the most commonly occurring issues, or if there are issues that occur as a result of the scanners, the scan results, you can sort of prioritize these issues as to which are the most critical and the most vulnerable issues that needs to be handled. Because as a developer, you may not have full context of all of these aspects, right? So sort of using a guided assistance in terms of prioritizing these issues, trying to give you more context in terms of how you can remediate these issues, and automatically raising a PR in order to fix these issues also can be something which can be very, very valuable in terms of addressing the toil that exists in security today. Again, and some of these things that I'm talking about, we will show these features in action, and that's what William's going to walk through in a few minutes. In terms of CD, we spoke about how it can be, GenAI can be used just like how you generate code. You can also generate pipelines. You can configure these pipelines, which are essentially like YAML files for specific deployment tasks. You can use that for detecting and alerting on deployment failures. You can analyze the log metrics for performance bottlenecks. Now, another concrete example that we've seen sort of being helpful is, now some of you might have heard of the Open Policy Agent, which is essentially a way to enforce governance in pipelines. So now OPA essentially is, for instance, if you were to say, like, I don't want to deploy into production and I want to make sure that my test cases are like some of these test cases are met before I do that, you can enforce that using OPA. But writing these policies is not fun because it's all essentially Rego syntax. So whether you're dealing with Rego syntax, whether you're dealing with SQL, whether you're dealing with YAML, essentially you can come up with a way to, if generative AI can be used in order to generate all of this complex syntax by using natural language input. Some of that also can be Toil, but at the same time, if you were to use and enforce governance, we can make that process a lot more easier using GenAI. Right. So let's talk about harden. So harden is basically like if you were to increase the resilience of your systems, chaos engineering is something which some companies might be doing. Some of them might be aspiring to do. Some of them might be sort of wondering where to start. That's where AI could help. You could help by sort of discovering the services in order to figure out exactly which ones which ones have had traditionally sort of are traditionally weak or traditionally need to be hardened. You could sort of look at what chaos experiments to run, and it could also, an AI could also help you author some of these experiments. Like if you were to author an experiment which sort of maybe you're sort of looking at hogging the pod hog or memory hog, CPU utilization. Like it depends on what types of experiments you'd like to run, whether it's infrastructure experiments or service or application specific experiments. I could help with discovering these services to start with, and also orchestrating and trying to help you identify what experiments to run and at what frequencies in order to build a much more resilient system overall. We talked about feature flags. Now, refactoring is also a very interesting use case with generative AI. Now, some companies have started to already experiment with this, and it is not an easy problem. And oftentimes, that's kind of like where the most toil lies. It's not about writing fresh code, right? Like when new engineers start in organizations, or when there is newer versions or newer features, it's always built on top of existing code bases, and you have to deal with sort of different versions. So how do you remove some of this toil or help with refactoring. How do you identify flags that have been stale automatically in order to clean up those flags, consolidate potentially like old and redundant flags as well, and help manage the lifespan of these flags. That's also an aspect where Gen AI can play a pretty key role. And a couple of other things I'll mention is in terms of cloud costs, as we talked about how cost is important. Now you can essentially enforce policies in order to clean up your cloud assets. Like for instance, you can say find all the unattached EBS volumes, S3 buckets, or underutilized EC2 instances and clean those up. And the what we've been experimenting with is this open source feature called open source capability called Cloud Custodian, which essentially also uses a way to enforce these policies. Now, you think of these policies essentially as a bunch of YAML files, which can be enforced using a Lambda function in order to go and crawl your cloud assets and clean those up periodically. But again, authoring these policies is no fun. So how do you make that process a lot more easy? Yeah. So number one, how do you sort of talk to your core files, your cloud APIs, and get the insights that you need? And that's something which generative AI can help with. And finally, authoring and enforcing these policies also is something which Gen AI can help with. And the last example I'll mention is around around dashboards itself. Of course, like this, in terms of the use case, it's not something that's new. It's something that people have been envisioning, and some companies have been, have been doing for some time now. But the advancement of Gen AI makes this so much more easier. You can get recommendations on these are the aspects that there are where there are bottlenecks, or if you can ask questions like where have I, like what has been my frequency of deployments and how has that changed over the last quarter. And you don't have to sit and work on slicing and dicing of this data by yourself. You can use Gen AI to convert that into SQL queries, or in our case, we use Looker. So as LookML queries in order to automatically surface those dashboards to you. So I spoke about a bunch of use cases, and before we jump into the demo, I'd like to sort of summarize this for you. So I know there's a lot in terms that we covered, but it's not comprehensive. There is still, if you sort of look deeply into the overall software delivery lifecycle, I'm sure you'll find a lot more interesting use cases and scenarios where there is toil, and that you can reduce that 70 or 80% of the time that developers are spending and shrink that significantly. But one framework to think about this is as follows. So essentially, as a DevOps engineer, you're sort of looking at generating or configuring, whether it's generating a YAML file or configuring a pipeline. And then you're looking at ongoing operations of that, right? Which is, how do I operate that pipeline? How do I make sure that it's optimized if there are any bottlenecks? How do I extract analytics? How do I consolidate my pipelines? How do I harden my systems? How do I deal with optimization of my cloud costs or other aspects? Like those are all more operational in nature. From a developer standpoint, when you think about generation or configuration, I think that's pretty straightforward, which is generating code or refactoring code. But if you're looking at operations, you're sort of looking at aspects where you're looking at the day-to-day toil, like could be simple things like summarizing your release notes. It could be stand-ups even that could be automated. It could be summarizing PRs, things like that. So these are some of the some examples that that we've sort of compiled. But there are a lot more out there which can be internalized no matter what role you're playing in your organizations. You can sort of internalize these use cases and see exactly where Gen AI might be applicable. So, in conclusion, what I want to emphasize is, while it is important to improve the coding efficiency, and coding, as I mentioned, is really one of the joyful aspects of a developer, and that's kind of where one would want to spend more time with. It is also important to address all the other aspects of that toil as well, which includes build deployments, which includes security, resilience, sort of looking at the overall developer experience, platform engineering is another area which is gaining a lot of traction in terms of enabling self-service, optimizing for cost, optimizing for software delivery bottlenecks. Now, all those aspects also have to be looked at. It has to be looked at very holistically in order to really help address and improve and increase the velocity of software. So with that, I'd like to pass it over to William to show us some of these things in action.
Great. You should be seeing my screen now. All right, to sort of get everyone situated, I'm going to first sort of talk about this pipeline construction. So what you're seeing on your screen right now is a harness pipeline doing build and deploy. And the idea here is that anytime I deploy or push code to my GitHub or any of my other code bases, it's going to trigger this pipeline. On the way, when I have a develop branch, for example, it's going to deploy that as a snapshot to QA. In order to ensure that that build is successful, we need to do a bunch of testing beforehand. So we're preceding that with this build and test step. If you're looking at it, we've added a couple lint steps, some security tools, an image or a build step, and then we're scanning that image with a couple more security tools. So let's just run this pipeline and see what that looks like. Normally, this would be triggered, like I said, by a commit to a code base, but in this case, I'm just going to run it manually. So in this case, we see the pipelines running, and it's going to start kicking off some of our tests. And this is a fairly simple, straightforward pipeline, but you can imagine as the complexity of your code goes up, there's also complexity in the testing tools you're using. There's a lot of jargon in these tools that can cause problems for a new developer who's not maybe familiar with the stack of tools you're using. And so this is one of those places where it can help us out. So we're seeing that the lint step is running now. Should be done in a couple more seconds. And while that's happening, we're also building the image. While we're waiting, yeah. So we failed, which is not ideal. So let's dig into why that failed. So normally, in a normal pipeline, I could dig through all my logs to try to understand why it failed. But in this case, there's a little nice Ask Ada button. So let's just ask Ada and see if we can get to the bottom of it. Oh, okay. This is pretty straightforward. While I was creating my code, I forgot to remove this output variable, right? And while this is probably not a huge, issue early on in my coding journey, as the code base grows and there's more of these unused variables, the complexity day to day of me having to sort through them and figure out which ones are valid and which ones aren't pretty severe. So the fact we can catch this early is great. So this is the first pass. So you can see that from a CI standpoint, we have a lot of this helpful help from Ada in terms of determining what exactly failed and why it failed. I'm going to skip over the deployment step, but this works very similarly. There's if anything fails, we can ask Ada for some recommendations, and it will sort of help us get there without us having to jump onto Google or go through Stack Overflow digging for the answer of what this obscure error is. So jumping into the next thing is we're seeing that we actually have some security test fails happening at the same time. So in order to get my code merge, I actually need to resolve both of these. So we'll see that we have this bandit step. It's failed, and we actually have this OPA policy configured. It seems to be saying that I've introduced a new critical vulnerability, which is not ideal. Let's go sort of dig into why that's the case. So if we look at the security test tab, we have two categories here, just to help everyone get situated. We've added apparently one new critical. There was one existing. So these are the new ones. So this is stuff I've added as part of my PR. And if we're looking in here, it seems to be telling me that my hash algorithm, which in my code base was using MD5, is actually not the right algorithm to be using. I should instead be using SHA-256. Well, that's really easy to fix. And again, if I had committed this into my code base, probably be fine for now. But when the security team finds it, I may have to go do a database migration to fix all of these, which would be super time consuming and painful. So if I can catch it now, great, saves me a bunch of time in the future. And what we're seeing on the SDO page is we actually are seeing all of the occurrences of this. So if we dig briefly into some of the other repository fixes, it looks like I've also introduced a SQL vulnerability, and I've introduced it in a couple places. So this, very straightforward, I can just kind of do the same thing as see, oh, if I just change my code slightly, and rather than form the string and instead use the execute function, I'll resolve my SQL vulnerability. So these two very quick changes allow me to merge my code. So, remove a little bit of the toil that I would introduce for myself in the future. So jumping into the next thing, post deployment, one of the things that we bump into is you want to make sure that you're not in a situation where I've deployed a bunch of stuff and it's costing me a bunch of money over time. And so I'm not super familiar with it. I think it was introduced earlier. I'm part of the STO team. But as a team lead, occasionally get prompted to go, hey, your costs have exploded. Can you go in and figure out in your dev space what exactly is going wrong? So I'm not super sure what these are. Maybe I'll get myself situated. This looks like a bunch of jargon to me. So why don't we actually just see if Ada can help us learn about this rule? Because I'm not sure what the acronym ASG stands for. Oh, this makes sense. It's the auto-scaling group. So, okay, so it's telling me that if I don't have these constraints for my auto-scaling group, it's going to basically turn it off. So let's go maybe construct a new one. I'm trying to make sure that my team has the right things situated. So we'll just start with test and see where we can get. So we'll create a new rule. And I don't know, I think maybe a good starting point is let's just say that I don't want to have my infrastructure up overnight. So in this case, we're going to say stop any EC2 instance that's been up for longer than 8 hours. This actually looks super reasonable, so we can apply this script. So in this case, I could save it, but let's go a step further. Maybe in this case, as the team lead on my team, I want to make sure that I know who exactly owns each instance that's deployed. That way I can track down and determine before I just shut it off, are you actually using it? So in this case, I'm just going to make sure that an owner set. And in this case, yeah, that looks reasonable. If the state's running and there's a tag and the owner is absent, it's going to stop the machine. So this way, if the machines keep being turned off in developers, they'll maybe ask, and I can say, hey, make sure you set the owner so I know who you are, and I'm not, I'm enforcing the fact that we're not ending up with all of these artifacts floating around my cloud that I don't know and I'm paying for overnight. Okay, so that's cloud cost management. And so then sort of jumping into the next phase here, it'd be nice to get a sort of a view over my deployment pipeline. And so this is the dashboardings, and Harness does a great job of providing a whole lot of metrics. I would say the one downside maybe is, again, if I'm not familiar with Harness or all of the tools, there's a lot of data to sift through when I'm creating my first dashboard. So let's jump in, and let's just say I want to add a new visualization. Well, I'm prompted with all these things, and I'm not entirely sure what I want to do first. So let's dig into Ada. So if we create a new widget through Ada, since we started with a CI pipeline, maybe let's start there. So maybe I want to know where are the blocking issues in my pipeline and are all of my pipelines healthy? So let's maybe say, what is our build success rate over the last 14 days? That maybe will give me a picture of where we are. Great, Ada's thinking. Great, so this looks pretty good. We're actually pretty high on our success rate, but it does look like there's a big spike in failures. That's pretty cool, so let me go dig into it. So if I look, I have this 3% jump. If I click on it, I can actually dig in to the data and I'll get an export or CSV of all the pipelines run. And I'm seeing that there's a lot of successes, but if I have a failure, I can quickly just jump into that pipeline. Since we were also talking about, security test orchestration, let's maybe ask about our active issues. So how many issues have we discovered over time for the last 7 days? We had a huge spike here, which makes me a little bit worried. Let's maybe follow up with another one, and let's actually ask if it can break it down by given severity levels. In this case, I'm asking for a line graph. I thought that might be a good idea. Maybe not the best idea, but I can quickly realize that this wasn't the right idea and just quickly edit this. So I'm going to edit this to a graph and change it here to instead a line graph. This makes a little bit more sense. So Ada sort of shoved me in the right direction, and I'm able to tweak it however I want. Well, we're seeing we have a couple of these 9.5, so maybe let's go look at them. So, whoops. Let's click on here and look at the table view, and we're seeing that we have this 9.5. So let's actually go look at it. And it's going to take us right back to the pipeline we were looking at earlier, and we can see that it's actually, I have this issue, and if I really wanted to, I could create a new ticket so my dev team could pick it up and fix it, or I can kick off an exemption, and I have the answer of what can be fixed right here. So between all these features, you kind of have a ability to have yourself a dashboard where you're being able to triage any issues you want to see by creating graphs, and then there's little helpful hints all over the platform that give you a view into ways to fix it and remove some of the toil. With that, I think that ends our demo. And there's a small note. If you want to see where our demo is, there's a sign up here with some extra information. And we have Chaos Carnival coming up, starts tomorrow. So if you want to sign up, there's a link at the bottom.
Awesome. Thanks, William. So William just shared a few examples of how we're using GenAI. There are a lot more, and I'll paste a link, a blog link, essentially, which sort of enumerates all the features that the harness offers today in the world of GenAI. There's also a lot of videos that we have up on YouTube if you'd like to check out our playlist. And we have a Chaos Carnival that's coming up tomorrow. And we have some exciting sessions lined up in case that this is an area that is of interest to you as well, to check it out. All right, so that concludes the presentation and the demo. Switching over to Q&A, I think we're getting a few questions. So if you have any questions, feel free to post them in the chat window or the Q&A window, and we'll take a look. The first one we have is if we integrate with SNCC, and how do you complement that at the code and the build phase? Will, do you want to take that?
Sure. We have integrations through STO that are kind of drag and drop off the sidebar. So you can drag in a SNCC icon, and then we'll ingest the data, and that feeds it into STO. And so that allows you to configure your own pipeline to scan and push. And SNCC supports a bunch of modes, so you have the ability to run against your code base or your Docker image. And similar to what I showed earlier, you can swap them out as needed.
Awesome. Next question is, if there are, from Michael, are there any programming languages that Ada can support better than others? So it depends on the use case, I guess. So let's say, for instance, if you're looking at the feature flag use case I was talking about earlier, where you want to instrument your SDKs automatically, wrap code behind flags, or if you want to initiate like flag cleanup or flag or code refactoring, all of that is programming language specific. So it does work better in some programming languages than the others. Like, for instance, obviously Java, JavaScript, and in some even Go and so on. There's some good accuracies and improvements that we have seen, especially for those specific scenarios. Hopefully that answers your question, Michael. Next question is, how do we control hallucinations in the results? That's a great question. I mean, how do you, for instance, like how do you know that the answer that you're getting is accurate? and then further and then figure out exactly if that's something that you want to accept or not, right, before you apply it. So it's a tough one, to be honest. So we it depends again on the use case. So for instance, what we've been doing is we've been looking at sort of bucketing the exceptions, errors, and so on across different use cases and different swim lanes, if you will. For instance, like Kubernetes or traditional VMs, and seeing if these exceptions and if the suggested fixes make sense, and looking at the accuracies. And some of it has been manual, but some of it also has been like, okay, before you apply, can we see what the recommended syntax is, and so on. Like in the case of STO, for the example that Will was sharing, we actually expose the prompt to the user, right? Like you can go and change the prompt. You can configure exactly if this is something, like if you want to change the resource ID to a different type, and get and fine tune and get a better answer. But it is a tough problem. I don't think it's not something which we have an easy answer to. But a lot of it is we're sort of looking at creative ways of prompt engineering to refine the accuracies, and also a lot of manual testing across swim lanes. That's kind of what we are doing currently. Okay. Next question: how do you think about the roles of developers and DevOps and platform engineers evolve with Gen AI? Is there a cause for concern about replacement? Okay, yeah. So I think this is a great question, right? Like we hear this all the time. So the role for developers and DevOps platform engineers. So one way to sort of think about it is like look at what are aspects, like how does your day-to-day look like today, and what are aspects of your day which you might qualify as toil, and internalize Gen AI in terms of addressing those use cases, right? That's how you can 2x, 4x, 10x yourself potentially. You can maybe there are tools out there that can help you do that, or maybe there are things that you might have to build yourself, right? But a good way to start is sort of looking at like what are aspects that you would qualify as toil in your day-to-day, and really internalizing the use cases, internalizing Gen AI in order to help address that. In terms of replacement, I think this is a classic argument. We hear this all the time. It's personally, it's really a way to convert you to a 10x engineer, no matter what your process is. It's really going to help augment your skills. That's kind of where the technology is headed. And there are some aspects which can still be which can be automated, which where like 90% is toil. But for the most part, like it's really sort of looking at how to improve the analytical input that the users provide in order to get the outputs that they need. The outputs are always as good as the inputs, right? So have there been any concerns around privacy and security for the use cases that were demonstrated? What measures are being implemented to ensure privacy and security of users? Now, privacy and security is the first is one thing that comes to mind. It's almost always the first thing that people think about in these scenarios. The issue sometimes lies in the one of the top concerns is like what data are you sending to back to these models? Are you training your models, retraining your models based on the data? Where do those models reside? Do they reside in the customer environment, or do they reside with the vendor? Are there any PII information that's being transmitted as well as part of your prompt? Now, there are various guardrails one can build for helping address or alleviate some of these concerns. I'll give you an example in terms of what we did, especially for the cloud cost scenario. Now, cloud cost management, even the cost data might be something that might be private to an organization. So what we've essentially done is we've taken the input through natural language, and we've essentially converted that to a SQL, which we're then using to query our backend systems. Could be BigQuery, could be Looker, could be anything. And then that is queried against the customer environment. the results ultimately is what is rendered to the customer. So we're using GenAI only for the query conversion or the query translation, right? There's no exchange of data that's happening. That's one. The second is that the use cases also sometimes, I mean, it depends on what it is. Like, for instance, if you're looking at exceptions and errors and so on, there's a ton of external data that's available, Stack Overflow and others that the models have been trained by. So you don't necessarily have to rely on specific customer data. And in scenarios where you do have to train using customer data, and that the refinement it can have several degrees of improvements. Like, at the most basic level, you could look at prompts. The second is when you can look at RAGs, or retrieval augmented generation, where you essentially look at augmenting an existing model with information, and look at a combination of information retrieval as well as the model in order to extract, in order to refine the accuracies. And finally, you're sort of looking at the model itself, where you're retraining that model, right? So in the first one or two scenario, like if it's prompt based or if it's RAG based, it's for the most part benign. And only when you sort of start to use this data in order to fine tune the models, it can get tricky. And again, if those models reside in your own environment, and if you have access to it, and if you have the right guardrails to those models, then that's something which can protect you as well. And obviously, in terms of PII and so on, we've seen, we have also implemented some aspects where you could sort of scrub the information, scrub the input of any kind of potential PIIs and so on, and then issue the prompt. Again, none of this is foolproof, right? We're constantly working on refining it. So that's kind of where we are. Okay. The next question: how can Harness potentially help democratize code development by using Ada to help develop and refine code from junior and non-technical users? Okay, so William, you want to take that? Or?
Yeah, I can take that one. I think, what I was showing here was that you end up with a lot of logs that are very difficult to interpret. After you've had years of experience, it's very easy to go, oh, that error message corresponds to XYZ. Ada does a fairly good job of explaining that. So when you get failures in your pipelines, you end up with a situation where it becomes a learning experience for your junior engineers. The same thing sort of applies as you swap between tech stacks. I'm not super familiar with cloud cost management, but I can jump into the platform pretty quickly, ask it to explain some roles to me or generate some stuff. And that gets me over that learning curve where I don't know what to Google, I don't know what to ask as a junior potentially. But once I have that example, I can sort of start looking at Google for those terms. And then it gives me a sort of way to get my foot in the door. And then it kind of just collapses that the time it takes for you to mature through a tech stack.
Cool. Another thing I'll mention is that it's not specifically related to generative AI, but we do have another module called IDP, or the Internal Developer Portal, which is essentially built on top of Backstage, which is an open source product that was developed by Spotify, which can help with self-service. So whether it's self-provisioning of, if you want to, of services, accessing documentation, helping ease onboarding, all of those aspects is something which the IDP can help address as well. And of course, you can sort of think about what elements of GenAI that you can infuse into these aspects as well. Okay, there's actually a lot more questions here. So what I'll do is I'll take one or two more because we're sort of nearing the hour, and Cody mentioned that we need to end 5 minutes prior. So, okay, so for folks using Jenkins for CI/CD, what are the benefits of using Harness with Jenkins? Okay, this is a great question. I think there's a lot of blogs that we've written. I'm sure if you Google for Harness and Jenkins, you'll find all kinds of comparisons. I'll give you a short version. Jenkins is really sort of it's had its time, and it's most companies have sort of moved on since then. I mean, there are some that are still it's still popular because it's open source and it's free, but at the same time, I think there's there's a lot of toil that's associated with using Jenkins across CI/CD, right? Especially if you were to extend those scripts and in order to do different types of deployments, canary, blue, green, what have you, or try to integrate like a security into it or verifications and monitoring, all of that can result in toil. And we do have our own CI offering. Do encourage you to check it out. And it's something which also has generative AI in terms of like test selection, in terms of optimizing your builds. And we recently launched a source code management offering called Gitness, which is a lightweight SCM. So do check out that as well. What is the expected ROI percentage of effort and cost compared to the reduction of toil? Now, that's a great question. I think one thing that's top of mind for everybody is like, what is the impact of AI in my organization and how do I track it? And sometimes we hear like practitioners and customers ask us this question because they want to make sure that they're able to articulate these answers to their higher ups as well. Now, there are various ways to think about this. It's essentially like there is some amount of improvements that you can get with automation, like just plain automation, right? Good automation. And then the Gen AI is sort of one layer above that, above automation, really. So you can sort of look at, okay, for instance, let's take support tickets for example, right? Like you can look at how efficient you are in terms of automating the support resolution process. Or you could use like an assistant in order to or expose your customers or your end users to an assistant which can help answer their questions and thereby track the number of support tickets that is being filed over time and quantify that in terms of an ROI percentage. So it depends on the use cases. And of course, when you think about like aspects where there's code generation, code refactoring, and so on, it comes back to developer efficiency and coding efficiency. And that's kind of where I was quoting some numbers as like 30%, 20 to 30% improvements in that as well. So it depends on the use case, but it's important to sort of look at like what are the outcomes, what are the metrics, and then look at how AI can help reduce that. Whether it's the number of incidents, whether it's the number of support tickets, or other metrics as well. Probably take the last question before we end. So your demos are all used AWS. Is that the only cloud platform Ada works against, or does it work with Azure or GCP? I mean, it's interesting. So we don't use, well, we are like platform, like we are cloud agnostic. You're right in terms of that the use cases were very AWS centric. But in theory, that you could use this across any cloud platform, whether it's to build dashboards or whether it is to generate policies. So yes, it does work against Azure and GCP as well.
Yeah, I'll add to that briefly. It was AWS, but I think all the plumbing, all of the demo was running on GCP hardware. So
there you go. Yes. All right. With that, would like to thank all of you for attending the session. Hopefully this was very useful. Corey, back to you.
Awesome. Well, Harish and William, thank y'all so much for running us through everything today. I know a lot of time and work goes into putting together your talk tracks and then actually making sure that your demos work correctly. So great job today. And it was really a pleasure having you with us today on Techstrong Learning.
Thanks for having us.
Thanks for having us. Bye, Cody.
So before I release our audience, just a couple of final words. Today's session was recorded and you'll be receiving that recording via email here shortly as soon as it becomes available. But you can also find it living on the DevOps website at devops.com/webinars. I will be contacting 2 of our most engaged attendees to win those $50 Amazon gift cards. So ways to be eligible are sitting in your chats and questions. So thank you for those who participated, but it is not too late to become eligible. Simply fill out that webinar survey that is pinned at the top of the chat, and you'll also become eligible. I'd like to thank Harness for sponsoring our program today. And to our audience, thank you so much for your questions and your engagement. This was such a wonderful program, and we are so excited to have you here with us. So thank you so much for joining us, and we hope to see you at a future Techstrong Learning Experience. Have a great rest of your day, and you may now disconnect. Thanks again, guys.